Right, in this video we're going to actually determine the ranges of values of x which the graph of the function of f of x is equal to x squared minus 8x plus 6 is A, decreasing and B, increasing. Now you can actually do this without calculus for a quadratic, but let's look to see how we do it with some calculus. So if we write down f of x is equal to x squared minus 8x plus 6, and now we differentiate this, so we're going to get f dashed of x is 2x, and then the differential of this is minus 8. You differentiate a constant, you get nothing. Right, for a decreasing function, f dashed of x must be negative. So what we do is we take this and we form an inequality. So we've got 2x minus 8 is less than 0. And then if we remember the rules of inequalities, we can solve that. So in the first case we would add 8 to both sides, so we get 2x is less than 8, and then we would divide by 2. We'd be careful though if we were dividing or multiplying by a negative number, because that would have reversed the inequality sign, which is not true in this case. So we get that x is less than 4. B, for an increasing function, we want f dashed of x greater than 0. So we've got 2x minus 8 is greater than 0, and do exactly the same as before. We'll divide both sides by 8, solving it. 2x is greater than 8, dividing by 2, we get that x is greater than 4, and therefore f is decreasing for x less than 4 and increasing for x is greater than 4. Now, we can do that, we probably could use our knowledge of quadratics to do that for us. Anyhow, let's have a look at the graph. So this is GeoGebra Applet, and it is attached to the notes of this video in YouTube. So here we have our function x squared minus 8x plus 6. You can see the critical point is where this is actually a minimum, or sort of a turning point, which we're going on to look at next. If we look at the derivative of that function, the graph of it looks like that. It's actually a straight line, 2x minus 8, and we can see that below values of x of 4 that the derivative is negative, which means that for that, the blue bit here that we've done here, the function is decreasing. Okay, so just repeat that. For values less than 4, the first derivative, this derivative here is less than 0, i.e. all these values here are negative on this axis. Okay, and then we can see that the corresponding original function is actually decreasing. Okay, this particular point where it is actually equal to 0 is called a turning point. It's a minimum point. We're going to look at that later. And we can see here, if we click this one here, we will see for values of x greater than 4, this derivative is positive. All these values are positive. Okay, and therefore we can see that the function is increasing. Alright, so try to relate it to the graph. Like I said, this graph I will put in the notes of the video. And so, final one, so f is decreasing for x is less than 4 and increasing for x is greater than 4. This has been a video to show you how to determine algebraically whether a function is decreasing or increasing using differentiation. I hope you've understood, and I thank you very much for watching.